Vectors and vector notation. We have met vectors in the context of translations. So here we have a point A, which we can see in red, and three other points, B, C, and D. To go from A to B, we could go 6 units to the right and 5 units up. And we write that as 6 units right, 5 units up, or we can use vector notation and write it as 6, 5. So notice the top number here in this column vector is the amount that we go to the right, and the bottom number is the amount we go upwards. So horizontal is the top number, vertical is the bottom number. If we go from A to C, that's 8 right and 3 down. We'd write that as 8, negative 3. Remember, the bottom number is the vertical. For upwards it was positive, and therefore it's negative for going downwards. So can you predict what A to D is? Well, we know that it's 3 units left and 5 units up. So we'd write that as negative 3 because horizontally we went left, so it's negative. And 5 is positive because we went upwards. We have seen that we can use column vectors to describe the translation of shapes. So, for example, we've got a triangle ABC, we've got another one over here, DEF, and if we look at A, which is the point that corresponds to D, to get from A to D we've gone 11 across and 3 up. So to move one triangle, this triangle here, to this triangle here, is 11, 3. We could have another triangle down here. If again we look at the A, and G would be the corresponding point. That's 2 units that way and 10 units downwards. So we could write that using the column vector negative 2, negative 10. In the examples that follow, we will look at some uses of vectors in coordinate geometry.